Assalamu alaikum. This is Muhammad Abir Ahsan from Group 10, and our project topic is Moving Target Defenses and Cyber Deception Technology with Software-Defined Network in Cloud Computing. And our presentation topic is the presentation of the survey paper named Moving Target Defense Techniques. So before we start presenting this specific paper, let us have an overview of our project topic. So the first terminology is MTD. What is MTD? Moving target defenses is a defensive mechanism. The native of North America used this technique during the Korea Wars. In this technique, they attack quickly from the trees and then disappear into the woods and effectively moving the target for a counterattack. It's a critical military technique which also can be implemented in the networks. So from the networking point of view, MTD is a defensive mechanism that continuously changes the attack surface to thwart cyber attacks. And then our next terminology is cyber deception. Cyber deception is the deliberate and controlled act to conceal our networks, create uncertainty and confusing against the adversary's efforts to establish situation awareness and to influence and misdirect adversary perception and decision process. It's basically a defensive practice to deceive attackers by distributing collection of traps and decoys across a system infrastructure. So let's get back to our paper presentation. And as the first speaker, I will be presented these sections: the introduction, research background of MTD, the inspiration and development of MTD concept, and lastly, theory and architecture design structure of MTD. Section 1, Introduction. In this first section, the author has started with the effects of IoT. They mention that Internet of Things not only breeds the new normal of human society, but also supports the efficient operation of critical infrastructure in important national fields. But after the certain effects of IoT, they have proposed a very sensitive informative thing, and that is the importance of cybersecurity. While describing about the cybersecurity, they have mentioned a quote from the Chinese President Xi Jinping. And the quote is, "Without cybersecurity, there is no national security. Without informatization, there is no modernization." So we can realize from this quote that cybersecurity has been a very major issue for a national perspective. And to ensure the cybersecurity, the author has described that MTD has been a very developed and a large number in theories, methods, and technical research results that has provided the cybersecurity. Section 2, Research Background of MTD. This section has been elaborated in two different subsections. In the first section, the author has introduced us with the typical offensive and defensive models, and the second, the root source of asymmetric situation between offensive and defensive sides is analyzed. Section 2.1, the typical offensive and defensive mode. This section, we will divide it from the two different perspectives. That's first from the attacker's prospect, and second from the defender's prospect. From the attacker's prospect, network attacks are intended to analyze the targeted system and to find out the ubiquitous existence of vulnerability and network resource. Then the author has described about the cyber kill chain that has been accepted by most of the attackers. Cyber kill chain is basically a multi-stage segmental type instructive model that is proposed by Lockheed Martin Corporation. The left of exploitation of this cyber kill chain is to gather information and construct assault arsenal. The attackers mainly formulate attacks, tools, and methods in this side. And then the right of exploitation of cyber kill chain is mainly to carry out attack behavior and intend the damage scope. And including more and more, the attackers exploit similar vulnerabilities to enhance the offensive effectiveness. The existing defensive methods can be mainly divided into two blocks: embedded defense and structure remodeling prospect, that we can be very clearly understand by this following illustration that has been added into the slide. So let us try to understand the illustration. Considering the defect of a system, a block embedded defense method makes irregularity system state unreachable by using techniques such as access control and physical isolation. When it includes the access control policy, by blocking rule, it's prevent unauthorized access, and so the attackers cannot access system to get any sensitive information. For such a result, the sensitive information in a system information is secured and protected. And regardless of the universality of this kind of method, absolute obstruction, it becomes more and more difficult for the appearances of side channel attackers. Besides, the conflict and storage space explosion of policy sets emerge with the increase of the number of rules added. For structure remodeling defense, it mainly copes with the inherent flaws of targeted systems. Such as structures remodeling method makes network resource vulnerability unusable, and by inserting plugins and patching and so on. For instance, if the defender upgrade the system security and fix some vulnerability issues in the system, attackers cannot launch attacks without have a correct exploration of the system. We will try to describe this author section in three different subcategories. So number one is the certainty of network composition provides the prerequisite for attackers in long-term analysis. The attackers can pinpoint the targeted system by collecting information in a network. And after that, the more influential security threats can be created by combining all those prospects. But from a defensive method based, if the defense system had a prior knowledge, then this will be very difficult to enumerate all possible attack methods, to explore all potential resource vulnerabilities, such as we can say the gap between attackers' comprehensive analysis to target system and the defender's little knowledge to security threats. These all together combined the threats results in the information advantage for the attackers. Section 2. The static nature of network structure provides the necessary intervenient environment for attackers to implement intrusion. So what does it propose? Attackers can implement control through installing backdoor plugins. The longer the network system are used, the more time attackers will have to exploit vulnerabilities. On the other hand, it will be very difficult for defenders to detect new types of security threats in real time, because we all know real-time analysis can be very difficult. And if we add more, the lag of patch issues provides sufficient time for attackers to implement such intrusions. And for this consequence, long-term planning for attacks and real-time response requirements for defenders leads to time advantage for the attackers. And number 3, the homogeneity of network elements, and this will provide the living space for attackers to expand the damage scope. So the attackers can threat the entire network system by only finding one single flaw. Furthermore, the common vulnerability can be exploited in different kind of systems in multiple and divided attacks. On the other hand, the defenders will need to apply different defensive means comprehensively so as to achieve some of the antiviruses and patching vulnerabilities. But in order to improve the security, the defenders will need to mitigate all the vulnerabilities. As a result, the commonly effective attacks will mean the comprehensive defense approach, and that will lead to the cost advantage of attackers. Section 3. The inspiration and development of MTD concept. Now the huge question is how to break the asymmetric situation to achieve network security goal. The answer can be creating a conductive network environment for defense and by increasing the attacker's apparent uncertainty. Now this concept will be elaborated in the next two subsections. Section 3.1. The inspiration of moving target. This MTD concept has been inspired from the very popular subjects such as biology, military, and cryptography. In biology, the camouflage concept and the structures of human immune system has triggered. And as for in military, the technique of confusing opponents by constantly changing sides. And lastly, in cryptography, the mention they say that polymorphic is better than static. Section 3.2. Connotation and extension of MTD concept. To explore this concept, author has selected a definition. Let us read through it. The definition said, moving target defense enables us to create, analyze, evaluate, and deploy mechanisms and strategies that are diverse and that will continuously shift and change over time to increase complexity and cost for attackers, limit the exposure of vulnerable opportunities for attacks, and increase system resilience. For more understanding, we can review this figure. And this figure 2 has described the trend of attack benefit over time under traditional defense and moving target defense, respectively. Because under the traditional defense, for the static and uncertain nature of the network, the configuration space can be explored by the attacks gradually. Section 4. Theory and architecture design study of MTD. First, we will try to describe the MTD theory based on attack surface. The attack surface of web service is shown in this figure 3, and it consists of proof per attack, packet as the data, and socket as the channel, and IWOV as the method. Since there are different IP configuration and various versions of web service, the attack surface of web service can change over time by adopted MTD. MTD system as a triple TGP, where T refers to the service configuration, as it can be regarded as a set of configuration parameters. Then G refers to the system performance goals and security goals. And lastly, P refers to the system strategy. And after analyzing, it believes that MTD should ensure the system performance at first, and on the basis it achieves its security goal by increasing the diversity of the system configuration space and improving the uncertainty of configuration parameters. The MTD theory based on attack graph. In this figure 4, a network configuration is shown on the left side, and the attack graph of this network is shown on the right side. Each node in this attack graph refers to one specific vulnerability exploited by the attacker in this network. For example, if the attacker gains the rights of the host tree, it can gain the root privilege of host tree after exploiting its local sets. Based on the given network configuration, vulnerabilities, and connectivity limiting firewall policies, the success rate of different attack paths in this attack graph can be calculated easily. After analyzing those two theories, we can come to a conclusion that MTD should follow some strict rules. The first one is coverage. The MTD should transform all possible vulnerabilities. Number 2 is unpredictability. The MTD should have enough transformation space. Number 3, the timeline. That is the in-time transformation of the system. And 4th is superstability, where MTD should be able to cooperate with the existing defensive mechanism. And lastly, the functional equivalence. And that refers that the function that is being protected that also should be provided. Now, MTD architecture. MTD based on man-machine collaboration, which is to cope with the deviation of the data analysis and strategy formulation. By combining the results of expert experience with that of machine learning, it ensures that accuracy of strategy generation and the effectiveness of mechanism implementation. Let's see on this figure 5. The architecture of MTD transits from proactive defense architecture to reactive defense architecture. And if we look more, it gradually develops into architecture with evolvability. In order to balance the proactiveness and pertinence during the defense architecture with evolvability combines the advantage of proactive defense and reactive defense. It adopts predefined transformation so as to achieve defense without detection. So that's all from my side.